All right. Hey, everyone. Welcome to the MacMillan Space Centre. My name is Michael. Once again, from the Space Center, not from my kitchen. Fooled you there, didn't you? Yes, I'm here at the Space Center, and I'm here because we are preparing for an event on Saturday. There are still some tickets left if you'd like to join us. We are celebrating something that is our theme this week. It is the solstice. And if you also go into the comments on this YouTube page, you can also see some activities that we have developed with Let's Talk Science all around the solstice. And of course, you can go to our website to get tickets for our Saturday event. But today we are going to be talking about what the solstice is. And of course, joined with our trusted astronomer, Rachel. Hey, Rachel, how's it going?
Hello, good. I'm so happy that it's sunny outside.
Exactly. Before we get going into, the solstice, and of course, the basics of what that means is it's the longest day of the year, it's the beginning of summer. But, I've been talking with some friends recently about, what does the solstice mean? And it's interesting that I think recently I've heard some people talk about they have, personal traditions. And I find that really fun because, I think I do that as well. I also like develop some personal traditions around solstices and equinoxes. So Rachel, do you have any traditions around solstice?
I don't think so. Not besides trying to be outside for as long as possible and enjoy that nice sunlight. But what are your traditions, Michael? I'm very curious.
Well, I think like more so, like the winter solstice, I think because I'm inside and I'm sort of like thinking about, inside things and of course being with friends, it's that winter time. And I think the opposite would be the summer solstice, which is be outside, but also be with people. And of course, for me personally, last solstice, I was here at the Space Center. That we did an event around solstice. So I have the tradition of being at the Space Center, but also being, with the people of Vancouver. And hopefully we'll get some good weather. We're going to do the event rain or shine. Bring your umbrella. We have storytelling, we have activities, and we'll have our observatory opened up. It's going to be a really fun day to continue my personal tradition of hanging out with people and talking about the solstice. So with that tradition, Rachel, why don't you give us a little bit of some insight into what the solstice actually means from an astronomer's point of view?
For sure. So I'm just sharing my screen, so hopefully you should see a nice GIF of a sun rotating by now. And so I thought that it'd be a good place to start with the word solstice. So solstice in Latin means sun stopping. So at the solstices, the point on the horizon where the sun appears to rise and set, or more precisely, the seasonal movement of the sun's daily path as seen from Earth, appears to stop and then reverse direction on this day. And you see I have a little arrow here to show or indicate that reversing of the direction. And so in astronomical terms, we say that the sun's declination, it's this fancy word that essentially means what the sun's latitude looks like on our celestial sphere, appears to stand still or stop. And it stops and then reverses direction on this day. Now the question is, why does that happen? Well, we know that our Earth spins around its axis once per day, and it orbits the sun once per year. But we also know that the Earth's axis is actually tilted with respect to its orbital plane by 23.5 degrees. So let's first imagine Earth's axis being exactly perpendicular or exactly up and down with respect to that orbital plane. Now, if this were the case, then the sun would actually take the same path across the sky every day. But of course, we know that this isn't the case, and the Earth is actually tilted. Now, let's take a look at this plot of the change in the sun's declination, or that fancy term for the sun's latitude on the celestial sphere, throughout the year. And there are a few things that I want to point out on this plot, but I promise that this will be the only graph that I show you today. So first, notice on the left-hand side, there's that same number, that same 23.5 degrees that I talked about. So this is the variation in that angle of the sun in degrees. And we notice that on the left-hand side on this axis here for this declination angle, it's limited between positive 23.5 and negative 23.5. And it's not a coincidence. That's the same as the axial tilt, or the tilt in the Earth's rotation axis of 23.5 degrees. Now, if the Earth wasn't tilted, it was tilted by 0 degrees, then we would have a really boring plot here and it would just be a nice straight flat line going across. But because we do have this tilt, we have this variation between positive 23.5 degrees and negative 23.5 degrees. And the next thing I want to point out is if you look at the summer and winter solstices here, I've highlighted in yellow and purple, the declination, or that angle, is at a max and a minimum, meaning that the North Pole is tipped towards the sun, and 6 months later, it's then tipped away. And that actually affects the path that the sun takes across the sky. All right, so that's enough of that plot. Let's go on to a nice little video here. So because the Earth's axis is tilted, instead of taking that same path every day, here in the Northern Hemisphere, we're actually tipped towards the sun. So the sun takes a higher and longer path across the sky. Now, because the sun's path is longer, it spends more time in our sky, meaning that our days are longer too. Then you look 6 months later, the Earth is tipped away. So the sun takes a lower, shorter path across the sky. And so the days are shorter too. And so that explains why the summer months are hot. The sun spends more time in the sky, and explains why the winter months are cold, because the sun is traveling that shorter, lower path across the sky. So now we figured out that the seasons are due to the tilt of the Earth, and not because the Earth's orbit is this elliptical shape where it's sometimes closer and further away from Earth. So the seasons are really caused by the tilt of the Earth. You might also know that the seasons are actually flipped in the southern or opposite hemisphere. And that's because when the North Pole is tipped towards the sun, the South Pole is tipped away. And you can pretty much imagine this GIF, but just rotated 180 degrees. And that would give you what you would see in the southern hemisphere. So I think what an interesting question is, as a follow-up to this, is what about other planets in our solar system? Do they have seasons? Do they have solstices? Do they also have axial tilts? And that's a great question, because the answer is that every planet in our solar system actually does have seasons. Most have 4, like our Earth, but the seasons that occur on other planets are wildly different from the summer, spring, fall, and winter that we experience here. So what does that say about planetary solstices occurring on other planets besides our Earth? Well, remember that when we say, or when we talk about a solstice, it's really when the North Pole of any planet is tilted toward the sun. And we call that a summer solstice. We don't really care what planet it is, as long as it has a tilt and it's pointed or tipped towards the sun, we call that the summer solstice. And likewise, when the South Pole is tilted towards the sun, we call that the winter solstice, or rather when the North Pole is tipped away. So the calculation becomes pretty easy. We just want to figure out the time between the summer and the winter solstice, and we call that the solstice period. So I went and calculated it for all of the planets here. And you'll notice in the bottom I've said that the time is given in Earth-based units. We're talking about months and years in terms of Earth months and Earth years. Now, I can't talk about solstices without bringing up the Cassini solstice mission, because Cassini was my favorite spacecraft of all time. And I remember watching the stream of Cassini's final moments back in 2017, where NASA showed the last signals received from Cassini before it burned up in Saturn's atmosphere and became part of the planet itself. Now, I must admit, a few tears were shed on my part watching that stream, because I did love Cassini that much. But for more than a decade, Cassini explored the wonders of Saturn, its rings and family of icy moons. And it actually had 2 extensions to its mission. One was called the Cassini Equinox mission back in 2010. And immediately following that was the Cassini Solstice mission, the second extension to Cassini's 2-decade-long spacecraft journey. Now, it was named after the Saturn summer solstice that occurred in May of 2017, right when Cassini was going to end its mission. And the reason that they extended the mission is because it enabled the Cassini spacecraft to study seasonal and other long-term weather changes on the planet, and also on Saturn's moons. Now, in 2016, the spacecraft was sent on a series of final maneuvers to provide close-up views of Saturn's rings, with the ultimate goal of plunging Cassini into Saturn on September 15th, 2017. Now, the reason why they wanted to plunge Cassini down into the surface is because they wanted to protect one of Saturn's moons, Enceladus, and other potentially habitable moons from the small chance that Cassini would collide with them and spread Earth microbes, because we want to be very careful about contaminating other planets and other moons and anywhere really that we're visiting with human-made spacecraft. Now, before Cassini's final plunge, it sent back to Earth incredibly valuable data about the Saturn system. And I picked 4 of Cassini's scientific discoveries to share with you today. The first one being that Saturn's rings were found to be active and dynamic, which essentially means that these rings are a laboratory for how planets and moons form. The ring system is thought to be pieces of comets, asteroids, or shattered moons that broke up before they reached the planet. They were torn apart by Saturn's gravity. Now, these ring particles mostly range from tiny dust-sized particles to chunks as big as a house, but there are some even as large as mountains hidden in those beautiful rings there. Now, the next thing I wanted to point out is that Cassini captured the first complete view of that hexagon-shaped storm or jet stream that surrounds Saturn's North Pole. And it also discovered these giant hurricane-like vortexes, or vortices, I believe, at both the North and South Pole. Now, this massive hurricane is tightly centered around the North Pole with an eye, or hurricane eye, around 50 times larger than the average hurricane eye we would see here on Earth. So it is truly a massive storm that has this weird hexagonal shape to it. Now, the third discovery I wanted to share with you is about icy plumes spraying from fractures on the moon Enceladus. And this led to the understanding that the moon actually has a global ocean of liquid water hidden underneath a very thick, icy crust. And likely, this underwater ocean actually hides hydrothermal activity on the seafloor. Now, the reason why this is particularly exciting is because scientists think that life could thrive in this underwater or liquid ocean on Enceladus, just like extreme organisms or extremophiles live near hydrothermal events in the oceans here on Earth. And that's really cool because even with Enceladus's thick, icy crust, it's so thick that no sunlight can actually penetrate it. And thus, things like the process of photosynthesis that we would expect that life could do won't be able to do without that sunlight. But even with sunlight blocking it, extreme organisms that live near hydrothermal vents could thrive in these conditions. So that's kind of interesting to think that there could be life on a moon out there in our solar system. Now, speaking of moons, the last discovery I wanted to share with you is that Cassini revealed that Saturn's largest moon, called Titan, had rain, rivers, lakes, and seas of methane on its surface. And it also is shrouded in this thick, nitrogen-rich atmosphere that might just be similar to what Earth's was like long time ago. So that brings me to the end of Cassini's discoveries and also the end of our little solstice introduction. So Michael, I'll throw it back to you.
Awesome. So we've got 2 topics really. Like we have solstice, and then we sort of like had a look at solstice from the perspective of Saturn. So everyone out there on YouTube land, you can type in questions for Rachel up until for the next 15 minutes. Anything about the solstice, anything about Saturn and the solstice, or really anything else after that. And for all the viewers that may be watching on Telesoptic as well, of course you won't be able to interact, but for any future live Q&As, you can always come onto our YouTube channel. We are here every Thursday at 2 p.m. Now, Rachel, I'll start off with a question because just a little while ago I was setting up our telescope, and one of the things that I really notice around this time of year is just that angle that you were talking about and how high the sun gets up. And I didn't really notice it that much because I know I don't spend a lot of time looking at the sun with my own eyes, but when we were setting up the telescope, it was at such a steep angle. And it's really amazing when you compare that to perhaps when you can see the sun in your peripheral in the wintertime. Maybe you're driving, this happens to me when I'm driving, like late winter or fall, and this sun is like hitting your eyes because it's right there close to the horizon. But now in the summertime, it's like almost directly above us. It's wild.
It's an interesting point because I didn't even think about that until I took an astronomy course. So we started talking about these angles, and I went outside and I was like, oh, hey, there really is a huge difference. And that point about you driving in the winter and trying to drive through snow blindness is, I definitely experienced that. And it's not something that people think about, I think, from day to day.
Yeah, and one of the nice things is because our observatory is very close to some trees, and at first I was a little worried. A lot of times there are things that the trees obscure, but the sun, no, it's like directly above. There are no trees blocking that. We should have no problem viewing it as long as we do have clear skies. If we have clouds, we'll find some streams that have the sun on it. So let's get to some questions from our folks out there. And our first question comes from Sheila. So talking about in the northern hemisphere, is our summer solstice the winter solstice in the southern hemisphere? So I don't know if my nieces are out there in the chat. They live just outside of Brisbane. So are they about to go into winter, Rachel?
So that's a good question. So solstices are opposite on either side of the equator. So if we had winter solstice here in the northern hemisphere, then it would be the summer solstice in the southern hemisphere. And you might be able to reconcile that if you think about, for example, Hawaii has Christmas in the summer. And and so it's kind of weird to think about stuff like that it is directly opposite. And it really comes from the definitions, right? So you have, for us in the northern hemisphere, the summer solstice, our North Pole is tipped towards the sun, and the South Pole is tipped away. So you're really worried about whether or not that axial tilt of our Earth is towards the sun or away from it.
Right. And then, of course, you get some of those wild areas, close to the North Pole during the summer solstice, where it's practically 24-hour daylight.
Yeah. So I think that I would love to live somewhere where it's 24-hour nighttime, because I'm more of a night owl, being an astronomer as it is. But it is cool to think about that there are these extreme cases here on Earth.
Yeah. Well, of course, you would have 24-hour nighttime in the North Pole during the winter solstice, right?
Yes, there you go.
And I guess that brings up another interesting point, about sort of like the North Pole and the South Pole. So for people that live around the equator, do they not really experience seasons the way that we do, whether they're we here in Canada or those down in Australia?
So it's not as dramatic. So it's almost like when we have equinoxes, which is that kind of weird point in between. On that plot I showed you, we had summer and winter solstice on either side, on the right hand and left hand side, and then they had the poles tipped towards and away. But when we had the equinoxes at that halfway point on either side, the sun's rays were hitting the Earth almost kind of evenly. So the Earth wasn't tipped towards or away in that sense. So it's almost like that around the equator.
Right. Interesting. Let's go back to some questions on YouTube, Lem. Another one from our friend Pride. Given the position of Saturn, of the continual storm on Saturn, and Saturn is made of gas, are the seasons on Saturn marked by a tide of sorts, like a gas tide, perhaps?
Oh, that's a really interesting question. I'm going to more venture into the speculative part of this answer.
Let's be speculative. Yes.
Yeah. And the reason I say that is because we had the Cassini mission that went and looked at Saturn in close detail, but the mission only lasted around 2 decades, and I believe a year on Saturn is much longer than that. And I believe it would have seen half of a seasonal change or seasonal variation in Saturn for around 13 to 15 years, around that mark. So we wouldn't have been able to see a full cycle of seasons on Saturn. And with this continual storm, it's a little bit difficult to talk about because we don't really see these kinds of systems here on Earth, because we're just not big enough. It's not a big enough playground for us to see these physical events like these. And what's interesting about this hexagonal storm is that they did try to simulate that 6-sided shape here on Earth, and they used jet streams to do so, and they were actually able to do that. And there's a YouTube video on that where they, I believe, take streams of either air or water, and they shoot it in 6 directions and try to do that same 6-sided vortex. Whether or not they are marked by tides, I don't know. But I believe there is some sort of variation in either the individual vortices and the cells inside or within that hexagonal shape, or something like that. I'm not sure, but it's a good question, and I would want to go back to Saturn and see if I could answer that for sure. Send Cassini too.
Yeah. Well, it's interesting, if you are trying to study Saturn and study the changes that happen on that planet through its seasons, you do have to wait, quite a long time to kind of like go through those cycles, which of course would probably come into play, if we're thinking about life developing on perhaps one of its moons. Like, does going through any of those seasons affect what life may be there on Titan or Enceladus?
For sure, yeah. It's really difficult with planets that are further out like that, like for planets like Uranus or Neptune, with their years being longer than a human lifetime. It's hard to study something like that where you're looking for variations that are happening across generations.
Yeah. And then if we're going to look at some other worlds, and of course, Uranus, again, is also an ice giant, but its poles are directly facing the sun. So what would the seasons be like on Uranus? Because it's really tipped on its side.
Yeah, so Uranus is tipped on its side because we think that, as with a lot of things in our solar system, something probably came along and smacked it and ended up tilting it so it rotates on its side now.
Yeah.
I imagine that the climate on Uranus is still not as friendly as we have here on Earth, just because it does have almost crazy weather like Neptune has. Neptune has incredibly fast winds that are a few times the speed of sound. So having any sort of weather on Uranus that is anything but crazy terrible weather is hard to imagine.
So the pole that we see, is it always the same pole, or does it flip around, and does the opposite pole face the sun when it completes its orbital journey?
Oh, that's a good question. I don't actually know, because I think you're imagining when we talk about the moon how the same face always faces us because we're tidally locked. It's that gravitational sort of dance that we have with the Earth moon system, and we always see our partner's face or the moon's face, the same side, the same face. But I'm not actually sure if we do see the same face of Uranus all year round. That would be a good question.
I guess it would, it's more sort of like, does the sun see the same face as opposed to Earth? Because Earth, of course, is moving around faster than Uranus is. But the sun, of course, is having more effect of its seasons than we are. We're just looking at Saturn.
Exactly.
And Uranus.
Exactly. And I would imagine that if in the Earth moon system, if the Earth has a strong enough gravitational pull to keep the moon in orbit around it, then if the sun has that same kind of relationship where it has enough gravitational strength to keep Uranus in orbit, then perhaps the same kind of relationship does happen with the same side facing the sun.
Interesting. Now, if we bring it back to Earth and think about the seasons and the role that the seasons play in life here on this planet, and is there work out there, or do people study sort of like the work of how our seasons affect life, and perhaps there are astrobiologists out there that are looking at that and trying to find, when we are searching for that other planet, that other Earth-like world, is having sort of like the same kind of tilt that we do on this planet, does that play into the necessities for life?
For sure. And that's definitely a very interesting topic of study, because when we want to go colonize other planets, that topic of food is always really important. And for agriculture, we want to make sure that we are keeping in time with the seasonal rotation of crops, and making sure that these crops can actually live through these different seasons that are either much longer or much shorter or whatever it is around these other planets. And actually it does play an important factor in things like using solar panels as well, because you want to make sure that you're putting it where you have the maximum amount of sun rays hitting your solar panel. So things like energy also, it matters your axial tilt as well.
Interesting. My brain was going to go in another direction, but let's go back to YouTube. So our poles are magnetic. Are other planets, mainly is Uranus's poles also magnetic?
Yeah, so Uranus does have a magnetic field. It has a very atypical, I'll say, or a strange magnetic field. A lot of things with Uranus are very strange, including its weird tilt. But the thing about Uranus's magnetic field and also its magnetic poles is that they're not at all aligned with the geographic poles of Uranus. And that's also true for the Earth, but for Uranus, they're really, really far apart. I think they're almost 60 degrees off from each other, whereas for Earth, they're a lot closer together. But yes, Uranus is a very wonky planet.
Interesting. Yeah, I'll bring it back to sort of the Earth because, on Saturday and thinking about these traditions, I think, in science, thinking about the solstices from different perspectives, I think is really important to studying life here on this planet because it's so diverse. The life that we find, the vegetation, the animals that live in the Northern Hemisphere are very different from those that live in the Southern Hemisphere. So having a lot of these different perspectives, I think, come into play, and I wonder if even different cultures have something to say about our understanding of the solstices.
For sure. And I think that really plays into even looking at moon phases. A lot of different cultures use moon phases to base their what to do for every season, or when to do certain things like harvesting crop or preparing food for the coming winter. And I think that the solstice is another one of those things where people have different stories or different ways of using it as some sort of tool.
Yeah, because it is a marker of time. That's kind of like what we use it as. We say that this is the first day of summer, even though I always find that it's weird that it's the first day. It should be like the middle of summer, but yeah, we'll get into that. But, it is a marker of time for us. And it's a start of, a new season, which, for you, Rachel, you said, well, you want to get outside. You want to soak up as much of that sun as possible because it is out there for the longest period of time. And what do other people around the world, what do they sort of think about when they're marking this time? And it always does seem to come back to, community and being around people, because you want to share this time, this marking of this point in the year with other people. And I find that seems to be very synonymous with lots of cultures, that always seems to come back to community and to sharing.
For sure. And I think it's interesting that you brought up this point of solstice being a marker of time, because I do often get that question as why isn't it the same day every single time? For us this year is June 20th. Sometimes it's the 21st. And that's really having to do with the fact that Earth's rotation isn't exact. It's not that exact 24 hours. And same thing with our elliptical orbit. We do have varying speeds at which our Earth travels in its orbit. So in those tiny fluctuations, we have those discrepancies in the days. So that's why our solstice isn't on the same day, and why we don't, using pen to mark it in the calendar every year.
Yeah, and of course on Sunday is National Indigenous Day, and that leads into, we're going to have some really incredible storytelling that's going to be happening outside. Of course, we're not going to be inside yet, even though I'm inside the Space Center right now. Yes, I am in ground station right now. If anyone has visited the Space Center, I'm on the stage at ground station. But we'll be outside. Our storytelling is going to be outside. Dallas Yellowfly and Alicia Colley are two really wonderful Indigenous storytellers that are going to be telling their story, how the ravens stole the sun. And then you'll be in pods to kind of give you a sense of what it's going to be like when you come here. You're going to be with your pod of people, maybe your friends, and you'll be socially isolated. Probably bring your umbrella if it's looking like rain. And then you'll start off in their backyard, and then you're going to walk to the different station over by observatory. We're going to be doing some crafts related to the sun. And then we're also going to have our observatory, which is where Rachel and one of our staff are going to be. One last question comes in from Sheila. If June 20th is when the North Pole is closest to the sun, why does temperature get hotter as our summer progresses through July and August? I love this question, Sheila.
That's a fantastic question. Yeah. It has to do with something that I like to call summer heat lag. Which is this idea that the Earth cools really, really slowly. We're very lucky that we have this nice thick atmosphere, keeps all our oxygen where we want it, that we can breathe, but it also makes it hard for our Earth to cool. So even though the longest path that the sun takes, or the longest amount of time it spends in our skies, is on the summer solstice, all that heating that has happened heats our Earth, and it takes a really long time to cool. So that summer heat lag stretches our hotter summer months towards July and August.
I always think of it as, I don't think it's related, but I always connect the two. I learned during this Quirks and Quarks question show, somebody asked the question about why it gets cold or colder right when the sun rises. And the answer, which I found really fascinating, is that because when the sun rises, it actually heats up the ground, which has been cold overnight, and releases a lot of the cold vapor from the ground, making it feel on the ground colder when the sun rises. And then eventually, as the sun rises higher, it gets a little bit warmer. But just as the sun is rising, it does get a little bit colder than it was before, which I always found really fascinating. I don't know if that's related to why it gets hotter as the summer progresses, but you might be able to relate it to, here in Vancouver, we like to call our weather, January, because we have all this rain. It always seems that in June we get a lot of rain, and then in July and August we get lots of sun. So
yeah. I'm so glad that you mentioned that too, because I have noticed that in the morning, and I thought that it was just me that thinking that it was colder, but now I know that it is an actual thing that does happen.
Well, thank you, Quirks and Quarks, one of my favorite Canadian science shows. Well, that brings us to the end of this week's Q&A. Thank you, Rachel. Thank you to everyone out there on YouTube and TELUS Optic. Again, we have some extra videos with Let's Talk Science and some resources. Click on the link that's in our description, or you can go to our website to additional resources. And of course, you can go to our website to give us some donations. We really appreciate it. So for me, Michael, from the Space Center, see you next time.